In this tutorial, we will explore the remainder of Figure Composer's tools. As usual, let's pick a figure. Let's now see how the filter tool works. After choosing the filter, you must define two limits, low and high, within which the filter definitions will be picked and applied to each sample. Set the low limit and click the corresponding padlock. Repeat this for the high limit. There are two methods for applying the filter. Let's start with the default setting, which is random. Let's hear once again the original figure, before applying the filter tool. Click the Apply button to apply the filter to the figure. To each sample, a filter will be randomly applied from the settings, low and high limits. As we've seen before, you can use the original/modified button to compare the result with the original. Let's try something else, perhaps a band pass filter. We can also use the second method for applying the filter, the breakpoint functions. You can use these to control the evolution of filter gain, filter center frequency and filter resonance throughout the figure. Let's try a linear evolution from filter low limit, bottom, to filter high limit, top, in the center frequency parameter. At any point, you can save the modifications, choosing Save Over from the Figures menu, or Save as a new figure, choosing Add to Library from the same menu. In order to better understand the Outputs tool, we need to go to Audio Settings, and use the routing matrix to route the outputs 1 to 8 different physical outputs. Remember that, as we've seen in Tutorial 1, each sample has two outputs, A and B, that can be routed up to 8 audio buses, 1 to 8. Let's play back a figure. Notice that, in this case, outputs A and B are assigned to buses 1 and 2, which in their turn, are routed also to outputs 1 and 2. Let's now change something. For example, let's assign buses 3 and 6 to outputs A and B for each sample in this figure. Check the meters in the background. If you're using an 8-speaker system, now the figure should sound in speakers 3 and 6. You can click drag to reassign outputs very fast and easily. Let's now spread the figure throughout the 8 speakers. You can also randomize the output assignment. And limit the randomization to a specific number of channels. Besides the Transposition tool that we've covered in the beginning of this tutorial, there's also Trasposition too. Just a quick reminder, with the Trasposition tool, we can assign new values for sample playback rate, for each sample contained inside a figure. Just click drag in the Trasposition multi-slider, and there it is. Now, once inside the Trasposition 2 tool, you need to define two envelopes, one for high limit, and another one, defining the low limit. By default, the range is set to 4 octaves, but you can change this. These two limits will define how the transposition values will be randomly applied to each sample contained in the figure. Let's spread everything at a 4 octaves range. Since the procedure is random-based, repeating the operation will always produce slightly different results. Let's now use the envelopes to produce a specific result. For example, by creating a big dispersion at the beginning of the figure, and then concentrating all samples in the high region. You can use the Onsets tool to rearrange the sample time onset in several different ways. Note that, inside this tool, you cannot swap samples nor shuffle their order. You can only modify sample onset times. In the first tab, called BPF, you can use an envelope to speed up and down the sample rhythmic sequence of any given figure. Here, you can either choose to speed up or slow down defining new onsets based on a regular pulse, or you can use the BPF to rescale the existing onsets. In the second tab, called Pattern, you can define a rhythmic pattern that will be applied to the figure's onsets. If the number of values is less than the number of samples, then the values list will be looped until all samples are used. For example, a value of 1, in the values in milliseconds text box, combined with a 100, as the unit multiplier, will produce a regular pulse sequence, where each attack appears 100 milliseconds after the previous one. This way, we can change the unit multiplier and preserve the value list, in order to speed up or down. Of course, this tool is particularly useful if we want to produce specific rhythmic patterns. This ends this tutorial. Thank you for watching.